Network switches have made our lives extremely simplified and easy, and they do a lot of great work for us, but they also have security vulnerabilities that we need to contend with. What are those and how do we do that? Well, that's the conversation we're having right now.
You're watching IT Pro TV.
Welcome back to Security Plus here at IT Pro TV. Today is going to be all about port security, right? We have these switches in our networks. They send packets here, send packets. I guess they're frames at that level, but that's what they do. They help us segment our networks, but there's a device somewhere, some way that is connecting devices together. And since it has an operating system and rules for how it should work, those rules might be getting broken from time to time. They have security vulnerabilities we need to contend with. Wes, you have a few ways that are going to help us actually work around those problems and secure those environments.
Definitely, and there's a couple of things that this helps with. It does help with the confidentiality, the integrity, I guess all three when it comes down to it, right? Because there are certain things that can directly affect the availability of communications across our networks, but in some aspects, some of the techniques that we talk are also going to keep unauthorized users off of your networks from maybe directly trying to affect availability. So let me show you what I mean. We're going to start out when we talk about port security. Let's talk about what a broadcast storm is, right? Because that's one of the things that we need to do. We need to protect from broadcast or broadcast storm. So what is a broadcast storm? So I want you to think about a frame that goes into the switch, right? Now, like Dan's mentioned, what does the switch do? All right, well, the switch has to look at its MAC table or its CAM table, if you will. It's going to determine which ports that MAC address destination it should go outbound. But if that was a broadcast communication, all right, what typically happens? In fact, Dan, I'm going to challenge your knowledge. If I have a broadcast communication, who in my network does that go to?
Let's see here. So if it's broadcast, that means it's going out to everyone.
That's right, exactly. It's like standing up in the food court and yelling at your, the top of your lungs, right? Everybody's going to hear it. Now, they might ignore it, but everybody's going to hear it. So now the switch says, oh, okay, I'm going to send this to the all F MAC address, right? It's just 6 bytes of, if you will, of Fs, right? So that goes out all ports, all right? Now, these two switches that are connected, they see that broadcast, and, well, without challenging Dan again, what are they going to do? Well, they're going to broadcast it out all their ports. Well, guess what? That's also going to go back up to the original switch. And then we're going to get this crazy thing going on, and I'm going to just stop it right there. We've got communications that are basically looping, if you will, inside of our networks, right? And that's bad. If you've never seen or, experienced a broadcast storm, you can see things like gigabit networks, if you don't have some kind of prevention on this, literally go down to dial-up speeds, right? Because of all the excess communications on our network. And remember availability, all right? That affects the availability, affects your access, authorized users' access to, well, the networks that allow us to, connect to our data. So what we need to do is we need to implement some kind of loop prevention, all right? Now, loop prevention and broadcast storm prevention really happens with a protocol called STP, Spanning Tree Protocol. There are variants of it too, Wrapping Spanning Tree Protocol, but in essence, you don't really have to, I believe, on this exam, it's not a CCNA exam, right, in Cisco. You don't really have to differentiate between designated ports, root ports, and block ports, but now, what happens here is, just very basically, in STP, all of the switches go through something known as an election process, all right? And they determine through a series of parameters, hey, who is going to be literally the top of the hierarchy? And what they're trying to do is create this loop-free tree topology, all right? And what they'll do is we'll send communications, but what we're also going to do is, to stop that loop that's starting to happen, we're actually going to block some ports, all right? There are going to be certain ports, and that's why they're called root ports, that can communicate to the root bridge, right? But then there's also ports, if you will, that are going to be designated ports that allow forwarding to happen. And then finally, there's going to be certain ports that we say, we're going to block those ports. So that essentially is broadcast storm prevention or loop prevention, if you will. And it really happens with a protocol known as STP or Spanning Tree Protocol.
All right. Well, now we know that Spanning Tree can help us out with keeping those horrible bridge or loops from happening inside. I want to say a bridge. It's a switch. It's a multi-port bridge. That's how we're working nowadays. And that will keep that from happening. We don't want those broadcast storms either inadvertently or purposefully, if that were to occur. And that can from time to time. Now we got a mechanism to stop that from happening. Let's now continue on the idea of bridges with the BPDU guard system that you might find in these devices.
Definitely. So, we talked about, at first I said, hey, there's going to be a condition where a broadcast, that's normal communication, right? That's normal communication that can happen within your networks. Now, imagine if somebody says, hey, I know how to craft one of those packets that actually kicks off the spanning tree algorithm. All right, let me show you what I mean. So again, same switches that we have here, right? We have what's known as a BPDU, all right? That's a Bridgeport Data Unit, all right? It's technical jargon for basically, and this isn't the whole thing, you don't need to know all of the other sides, but it tells the root ID. Who's the root? Cost, all right? In routing, we talk about cost, right? How long does it take me? How many hops do I have to go through in order to get to the destination, right? Then you have a bridge ID and a port ID. That's essentially, and there's more around it, but that allows the switches to determine where do I send the information to which controlling switch, if you will, is going to be the root bridge, all right? That's your bridge protocol data unit, right? And if anything changes in the topology, well, we're going to go through this process again, right? They're going to communicate with these BPDs, right? And they're going to figure out, BPDUs figure out who the root bridge is, all right? Now, let's take a scenario where somebody actually crafts one of these frames maliciously, all right? There is the ability that if they can plug into your network, that's why we say here, if I've got physical access to your network, some things are going wrong here, and we could start to have problems, right? And if they craft one of these BPDUs, they could send multiple BPDUs into the bridge and keep forcing that re-election process to go on, right? So what, what BPDU guard does, all right, it makes sure that only certain ports, all right, and typically the ports that the other switches are connected to are authorized to send a BPDU, all right? And now how does this stop the attacker, all right? Well, think about an attacker essentially connecting to one of the ports on your switches, right? Crafts one of those BPDUs and tries to send it and forward it, let's say maybe in a broadcast, communication. Well, the problem is that's going to force that to go back on. We don't want that. Instead, with BPDU guard, it says, hey, I see that coming in on a port that isn't actually authorized and trusted to send that information. So what happens is the switch says, no, thank you. That's not coming from the appropriate port, and it doesn't allow that communication to happen. So that's a little bit about the BPDU guard.
Well, it seems like we need a lot of nannies to keep us out of the weeds, as it were, when it comes to these switching units. But because we need switches, we're going to have to implement these guarding systems. And they do work out pretty well and keep us out of the weeds, especially when those bad actors show their ugly hoodies and try to do something horrible inside of our systems. Let's keep moving on. Let's talk about one of the most interesting things that I think was probably one of the first denial of services that I encountered in my IT career, which was the idea of if you spin up a DHCP server, some service that's offering up IP addresses in an environment that already has a DHCP server, well, when machines start asking for those IP addresses, you got a fight on your hands. Who's going to win that fight? It's a really interesting thing. It can cause a denial of service. So we need some system for making sure that that doesn't happen. This is the idea of DHCP snooping, right, Wes?
That's right. And, that can be a problem, right? If we have somebody that plugs into your network, and we've had it done by authorized users that really weren't trying to, bring the network down, but unfortunately they did, where they plugged in, let's say, an access point into the network. It started giving off DHCP addresses, and now, unfortunately, our computers are connecting over to that access point for their DHCP process, right? So how would that happen? Well, it could happen with even authorized users, and it can also happen with unauthorized users. Somebody plugs in maybe an access point that starts giving off DHCP addresses, and now you get this denial of service because guess what? All these clients are saying, hey, I need a DHCP address. I'm going to get it from the access point rather than your authorized DHCP server. So let's take our same switches here. All right, DHCP snooping, what it does is it says, we're going to need DHCP process to happen, right? And that DHCP device, server, if you will, firewalls can do DHCP, a lot of devices can do DHCP, all right? But we're only going to allow this DHCP server that's plugged into this port to go through this process. Now, be familiar, just to have a passing familiarity with the DHCP process, right? Discover, offer, request, acknowledge. That's the DORA process. All right, but I'm not really worried about the last three process points, right? Because those are unicast communications that go directly to the endpoint that said, hey, I need an IP address, right? But the discover packet is actually, it is a broadcast communication. We've talked about broadcast, right? So what that means is if somebody plugs into your switch and can send out broadcast communications or listen out for broadcast discovery packets, they can say, all right, yeah, I got my DHCP server over here. I'll go ahead and offer you one of these IP addresses. So what this does is says, hey, if you can hear a DHCP message, you can only receive it on this port, all right? And then from there, the switch can make its determination of where to send it within the network. But our little rogue DHCP server, unauthorized or even authorized user, connects into your network, connects into the port on the switch, tries to send one of those DHCP messages, and it is blocked. Now, this doesn't just do that, because some people, let's say you receive a DHCP discover packet saying a legitimate client on your network saying, hey, I need a DHCP address. All right. The offer comes back, but the offer comes back on another port. All right. So it also pays attention to that. Which ports are these communications within the DHCP happening? All right. Because switching says connect two ports and forward information between just those two ports, right? I see another port start to get in the mix. That's not good, right? That's some kind of unauthorized access that's happening. So that essentially is what DHCP snooping is. Really just, at the end of the day, think about it as a way that says this port is allowed to send DHCP communications. All these other ports, no, we're going to block them. So that'll keep those unauthorized DHCP servers on your network.
It's funny to kind of think of how this cat and mouse game typically evolves. Hey, we got a problem. What's the problem? Well, putting out a bunch of IP addresses is really hard. We should make a service that does that. Automate that process. Cool. Why would anybody want to do two of those? I don't know. And as we start to see that progression, we have to build these mechanisms for controlling them so that these kind of things don't happen. It keeps us out of the weeds, both in security and as well as just accidental, discharge of our our poor networks here. Let's move on to the idea of MAC filtering. We see this a lot with access points. Wes, we're talking about switches today. Is that basically the same idea?
Yeah, and the great thing with it's, whether it's wireless or we're talking about a wired network, really MAC filtering comes down to the same principle. Let me show you what I'm talking about here. So we have, we have a few client PCs that are connected into the switch. We know that they have the media access control address, the MAC address, right? Well, when the PCs actually communicate with the switch keeps track of port to MAC address mappings inside of its CAM table and basically stores that inside of a database. Now, when somebody else connects to your network that is unauthorized, then what happens there? Well, they're going to have a MAC address as well. They connect. The switch will end up checking that little database, and it's going to say, I'm not exactly sure who you are, and you're not in that database, and I can't see any port mapping, so it essentially closes down the port. That's really, in a nutshell, what MAC filtering is, and it's just, when we talk about on wireless networks, it's just done on real wireless communication, right? Again, still going to be done with MAC addresses stored in a database. If it's an unauthorized MAC address, it doesn't make the connection.
That's right. And if you're working with Cisco equipment, they've got a lot of great functionality built in to help you really fine-tune that system and make sure that only those authorized devices are actually making a connection into your network. Let's keep going here. We got one more thing to talk about, which is the idea of using port mirroring. Now, I don't know if you're coming at this from this is an insecurity or security. How are we looking at port mirroring? What's the thing with that?
So when we want to dive in and see the communications that are happening between two ports, all right, let me show you what I mean. So we've got a series of PCs here, and these PCs are connected to the switch, but we also have a monitoring station, an analyzing station, if you will. And what we do is we say, we're going to take and specify a single port, maybe one in question, and we're going to map all of the communications that goes in and out of that port to our monitoring station. So this computer, PC1, is going to talk to PC2. Well, when that happens, there is a duplicate frame that essentially is sent over to the monitoring station. Now, PC2, again, part of normal communication, is going to communicate, if you will, back to PC1. Well, when that happens, guess what? It's also going to take that frame and it's going to forward it over to the monitoring station. Now, why might you want to do something like this? Well, you can do this with things like PCs if you want to understand the communication flow that's going on. You can also do it in things like voice over IP phones if you want to be privy to the conversations that are going on. So there are a few different things that you would do this for. But again, keep in mind at the end of the day, you might also hear it called port spanning. Cisco has their switch port analyzer span, if you will, and that's essentially what this is doing. It's allowing you to take the communications that are going in and out of one port, make duplicates, and then transfer that or forward that information over to another port. A lot of times it's going to be a port that's got a monitoring station of some kind connected to it.
Yeah, I've used this quite often to check for malware connectivity. That is there malware on my system? And if so, where is it reaching out to? What is the communications that it's making? Because most modern networks are switched in some way, shape, or form. So it's really important for us to be able to do that. And this is the best and industry standard for doing such action.
Sure. So when we're trying to identify a potential for vishing schemes, right? Vishing attacks, we've talked about that in our network attacks. It's a voice over IP based type of attack. Well, we can kind of be privy to that communication, right? We can see where is the communications going through. Are those frames being modified or manipulated in any way that might redirect that information to another port for whatever reason? So again, you can see that there are definitely a few different applications for it.
There you go. Well, now you understand why, port security is an important thing. We've got many switch networks out there and they have their vulnerabilities that we need to be able to secure against, and using things like BPDU guard and STP, as well as DHCP snooping and MAC filtering can really help us keep those systems in check and doing exactly what it is we want them to do and not bringing the whole thing down to its knees. We don't like that. It's a bad thing. So there you go. You've got that squared away. That said, we are out of time for this episode, but as always, there is more to come in our Security Plus series. We do look forward to seeing you there. Until then, have a great day.
Thank you for watching IT Pro TV.